Hi, Dad. Wait a minute. Okay. Um, did you expect a green screen? I actually, oops, have a green screen. And it's kind of the problem is my camera does not like the green screen. And I also don't need a green screen because I'm using a neural network, also artificial intelligence, to remove the background. And that is a really interesting process, and that's why I want to talk to you about how neural networks work and how we train them. That's where the artificial intelligence comes in, or machine learning, which makes a bit more sense. And so, off to the whiteboard. So, neural networks are, well, it's an algorithm, if you will, which inspires from neurons. And the basic idea is I have neurons, right, that are, let's say, the input neurons, and then I have other neurons here, let's say two layers, one layer, doesn't matter actually. And these are the output neurons and intermediate layers between. And so I connect every neuron to every other neuron. And so as you can see, this then creates a network of neurons. And so what happens is in the here I put some kind of input, and these then put in and then propagate through the network to find an output. And in my case, of course, it is the question is what is the background and what is the subject. But so this sounds really awesome and everybody gets this part, but actually let's dive into the math a bit. And because neurons are kind of interesting, and so the way this works is you have a neuron, single neuron. So you can say neuron here, and it has inputs, right? So input one, input two, many inputs to input n, of course. And so they're connected to that. But this is so these are inputs. Generally, we say the inputs are between -1 to 1. They can be other values, but this is what we kind of sort of use. So you need to convert all your inputs to that range. And then you have weights. So we have a weight. Every edge has a weight. And so you take your input, multiply it by the weight, and you create the sum of all weights, or a sum of all inputs, weighted inputs. And then on top of that, you actually have, in front of the neuron, you have an activation function, right? And that gives you your output. So basically, your output of the neuron is the activation function from the input 1 times the weight 1 plus the input 2 times the weight 2, all the way to the input n times the weight n. Of course, that makes sense. The interesting question is, what is the activation function? Now, there are multiple activation functions you can use, but one of the common ones is a sigmoid. So you'd have something along the lines of going from -1 to 1 that would have an output from Munst, which would then do something like that. So it doesn't trigger, triggers a bit, and then pump, falls over and triggers significantly. This in itself is, of course, not very useful because we don't know what weights to use and how to structure the network. And the interesting thing is, so we basically would then go and say, well, we need some kind of input, some kind of network. And the question is, let's think about our problem for now, because what we have is we have an image. On this image is a person, and then we have clutter in the background, stuff, right? And we want to convert this to an image that says, here's a person, and basically black and white, but we want to say, well, this is what we want to have in the image, and this is what we don't want to have in the image. So basically a mask. This would then, of course, be used. So we need to take this input, which is either black and white or in color, but doesn't matter. And then we need to put a neural network in between here. So let's think about this. Let's say, in my case, I have a video stream that is 720p. So that is 1028 times 72 pixels, right? Times 3 pixels, which is because, or 3 colors, red, green, and blue. And this is our input. Our output, on the other hand, is of course 1028 times 72 times 1, because we only have black or white as an input. And then later we'll use, of course, the mask, then can then later be used within the video processing tool to, of course, blend the foreground and the background. But the question is, how do we get from here to here? And this is where the learning bit of the algorithm. So what we have is we take a bunch of images, lots of images, right, that have a person on it, which are inputs, which are unfiltered, and matching to each image, we then have a mask, right? So let's use our red and greens again, right? And we then take the images and the masks that match, and then build a network. Now, how do you build a network? This is a bit more esoteric, and we don't have, there are ways to automatically build a network, but most of the time in deep learning, we use predefined networks. So we think about what's the problem domain. And in this case, I can very well imagine, I don't know necessarily know, but you can very imagine that you have an input layer, right, that has 1028 times 720 times 3. And often you do kind of the intermediate layers go smaller because we want to first detect objects. And then once we found objects, we want to make them bigger. And within this might be like 100 layers, 1,000 layers, something like that. And so a chunk of ends, which then gives us our output layer of, again, 1028 times 720, right? Well, this is our network. And generally we start off by assigning random values for the weights, right? But that doesn't help us, because that was, we put an input and we get output. So we have the input, which is feeds into here, and the output, which feeds into here, but we get an image, right? So here we get an image of the out, and of course it's, in the beginning it's just noise, and then we compare it with our input, or actually our well-known existing output. And there are multiple strategies to do this, but what we do is we look at our weights in here, and then we say we tweak the weights, and we try to get a better output. And this is what we call backpropagation. So we take our input, move it through the network, and then try to change a weight and see if it works better. And that's called backpropagation. So, and we do this, of course, not just once, but we do this like 1 billion times with all the different inputs and outputs. And as time goes by, our network becomes better and better and better. And so this here, which is called the loss function, or actually that's a loss function, which is a difference how to optimize things. And, and at the end, we have a network that then can take an input image and output a mask, and then we can use it for basically removing backgrounds. And so, at least for small installations, like let's say me or other people trying to remove their backgrounds for video conferencing, this is what is commonly used. Yes, and so this is how basically neural networks work. The question is, why do I use a white screen? Basically, I need to help my network a bit, because if you look at, let's say, places, if you have the more clutter in the background, the more the our neural network might get confused. And so I use a simple white sheet to reduce the noise in the background, especially around my edges. And because if you look at places like, let's say, like somewhere here, under the arms, you often get these artifacts, which you can see, and that's when the network just gets confused and doesn't know what to do. And this gets at the worse there's noise in the background. So I simply remove most of the noise by simply having a white sheet in the background, and that allows me to have a better result when it comes to the network mask. And that's how neural networks work. Hope to see you soon.